Hi everyone, and welcome back to our course. So let's continue to implement the zoom. Well, actually, part of the zoom was already implemented in the previous class, wasn't it? So now we're going to implement the autofocus, and I'm going to divide it up into two classes. First, we'll implement part of the function, and then we'll bring all the other elements into it, okay? So this will help us to understand the autofocus without it being all condensed into one course, one video. So let's open up our camera, and we looked at in our previous class how we can adjust the focal length, and we're controlling that by using the right mouse button, aren't we? So it adjusts the aperture as well as the focal length. So for now, this is what our first person is able to do. But at this stage, we want to add more complexity to it, more realism. So we're going to adjust the focal distance based on what object is in its path, okay? So the first thing we need to know is to adjust this here, I need to know how far the object is from where I am. Now, if I don't know how far the object is, I don't know the distance to put here. So, since I'm doing this manually, I need to find a way to adjust this until it looks good. But there's an exact distance between the camera and the object. And that exact distance is used to adjust the autofocus. So we have to find out what's the distance and how to measure it. So how do we go about doing that? Our character has a camera, so that helps. And using the camera, we need to find out the distance from the camera itself and the object that we want to focus on. So the actor, it could be the object, the subject in our scene, whatever it is. So let's see how we can find the distance. To do this, first of all, we need to use another tool or another feature that's made available for us in Unreal Engine. So let me show you what that is. To help us and to help us produce this, not exactly only for this, but it's quite useful for this feature, there is a resource called Line Trace. Now, what is Line Trace? Well, Line Trace generates a line kind of like a laser beam. Okay, so it shoots out a red line, and this is like a laser shot in the sense that when it shoots out, it will make contact with whatever object's closest to it or in its path, and it will identify the distance. So when it hits it, basically that's the point in which we want the autofocus to kick in. Okay, we'll show you exactly how to do that in this video. So let's do it. Let's demonstrate it now. I'll select right click and then select Line Trace by channel. And this is the one that I'll use here. So what I have in this node are the flows here, so I can flow in and out. And then I have the pin here for indicating where this trace starts. And it comes out, it comes in from here and where it comes out. So let's go back to our camera. Now we'll get our scene to find this camera. Okay, cool. So let's suppose that this camera is the first person character or the first person camera. So I have to create a line trace that comes out of the camera, and it will shoot in every direction. But when the trace hits the object, that's when it's going to start to focus our view. So here is the start coordinate. So where the line starts from, here's the end, is where the coordinate is going to end. Now in the trace channel, this is all about the visibility. So these are the values that we can alter. And I can also use the camera visibility. Okay, so here are the actors it's going to ignore. If I want to eliminate an object from the scene, then I can plug it into there. Something maybe, for example, I don't want it to trace or identify, I can put it into this part, and I can draw a debug type as well. So if I can see the trace, since it's invisible, or we can't see it, then it's not going to appear in the game. So here you could activate it or deactivate it for one frame, and that's as long as it's going to appear in the scene. And when you're programming, you can see the trace and understand what's happening, but you might find an error that you're receiving because you can't see it with the trace. So I can choose for one frame or for a duration. Okay, and these other options will show up, but I'll leave it for now just as one frame. Now there are these other options as well to do with the color, but we don't really need that at the moment. I'll just leave it visible for now. So in the end, I'll get the results of everything that will be done here. So let's go step by step. The first thing we have to do is knowing where the trace is coming from. It is key. So where is it coming from? Well, following the idea, looking at our camera, it's coming from here, right? So where does the trace leave? Let's think about this. If we analyze our camera, here's our camera model, and its location is right here around eye line. Okay, and in the center of the lens we have our pivot point. So it's going to come from exactly this location. That's where it's going to start from when it's in our scene. So all we have to do is this. Let me just close some of these things to make it a little bit clearer. Okay, back to our event graph. First thing we have to do is start from the camera, so we get a reference for that. And that's going to help us because it's going to start from the camera point. So what I have to do now is get the camera position. So if I type in get location, actually there are two kinds of locations we saw in the other class. So there are the relative position and the world position. So in this case, the world position is what we need, because wherever it is, we need the camera's position, okay, regardless of where it is in the scene. So we'll use get world location, and it will get the camera location in the world. Great. And then as you walk, this will always be updated to your location, and it updates here for us as well. So we have our start point. Okay, so let's go back to the principles and how we're going to work this out. We have to find our endpoint, don't we? So where does the trace end? Well, here you can see it's given us some coordinates. So I always try to vary this, because if I keep a fixed coordinate, then it will always fire, and it might be quite a short line from the camera. It might be too short for us. But if I keep 0 as the coordinate, then it's always going to point. So it can't be a fixed coordinate, rather a variable one. So we have to fire a shot that is, what should we say, that's perpendicular to our camera. And we have to find out where the camera is pointing at. Okay? And the shot will always be shot in that direction. Following so far? So for this, there's a camera node that we can use. And this does exactly what we're just trying to describe. So we can pull out from here, and we get forward vector. There we go. And it's almost as if there was a vector, an arrow at the front of where the line is going to come from. And it will point in whatever direction it's pointed at, and the vector identifies it. So if I point up or down, it's going to identify which direction I'm pointing in, or if I turn from the sides, etc. Okay, so we have the direction of where we're pointing and where the camera is pointed at. Now we have to work out the distance, or tell it the distance. So we'll get the direction and the distance for this line trace now, and these work together with the coordinate. So let's have a look at this. If I leave from here in this direction, let's suppose it's 3 meters here. This point here is our final coordinate. So it's a coordinate at the end of the line, right? So what we'll do is we'll get the initial point, the coordinate of 3 meters away from the camera, and also in the same direction. And this will create a point here. So beginning here with the trace, what we need to do first is define the distance that we want. So how do we do that? Well, how far do I want this line to reach? Because if I set a distance that's too big, then it's going to get objects that are too far away. Or if the distance is too short, let's say 1 meter, for example, it's going to stop early. If the object is 3 meters away, a distance of 1 meter won't find it, will it? So according to some tests, what we can do, I found, is we can use 4 as a distance. That's a good distance for us to be able to allow it to identify objects. So let's create a variable regarding or for that distance. I'll create a variable called trace length. Just type that in there. And we can use a float. There we go. Compile, and we'll type here the distance of 400, which is 4 meters. Now I have the variable, I can just add it in here. Okay, I'll get it. And now take the get forward vector into consideration. Now this is important because it's going to create an arrow in front of the camera with a value of 1, which is what Unreal Engine does. The value of 1 is going to come out from here. So if I multiply it by any other value, the result will be the same. Okay, so here if I multiply 0 by 1, the result's going to be 0, isn't it? Even though it's a vector, I can multiply everything. And this is the size that's being generated here. So a vector and size is what we're talking about here. So I need to add this to the initial coordinate. So 400 plus the initial coordinate here. So we can create a second vector here as well. To do this, I need to come here and add the initial position. And the initial position plus 400, which is what we chose to use. And we have the final coordinate. And now I have a beginning and an end defined here. And it will draw this line. Okay. So we have our line trace set up, which is good to go at this stage. And we've gone through all the settings in this node as well. And here we just need to define for 1 frame. Okay. And then I have to create an event because there's nothing that's going to trigger this at the moment. So if I press play, that means nothing's going to happen. So let's create an event for it. So let's think, when would we want it to happen? Well, when I press zoom with the right mouse button, right? So we want it to happen here when I press it. And then when I release it, we want it not to be active anymore. Okay? So we want it to shoot and then stop. Cool. So if you don't get the position you want exactly, it might miss the object and it won't come into play. So let's have a look how we can do this. Well, the main idea would be to create an event, but you need this to be happening all the time, don't you? So because it's always going to be looking for things. So let's use an event called event tick. This is slightly different to the other events that we've used in the past. It just triggers an event and it triggers it at every frame. So at every frame in your playthrough, it will continue to trigger the event. Okay, like a light switch. If the light's on, then it's going to be working. So you have to just bear in mind that's what an event tick is. You need to be careful though with the function that you're using, and especially in an event like this, because it's going to be working every single frame. So if this function is doing some heavy processing or doing something that demands much of your GPU, your processing time, then that's not going to be a good move. And sometimes you might experience crashes. So just bear that in mind. But in our case, we should be okay. So depending on your scene, just bear that in mind, okay? So use it in moderation is basically what we're saying here. Now, in this case, the event should work for us. It's only drawing a line here. It's not more complex than that. However, you don't need to check this every single frame. There's something else that you can do. Okay, so let's have a look at what else we can do to help us. I usually add here a delay after the event tick, just to decrease the number of events per second. And I use 0.25 here. And this reduces the number of shots per second. So this is just a precaution to help us in performance. And if you've used a line trace before, and obviously you're experiencing that, no problem. But let me just show you here what happens. So what's happening here? Nothing's happening at the moment, nothing's showing. Let's get a bit closer. And can you see that on the screen? So you see that tiny red square that's started to appear? So this is detecting that there's an object in its line of sight. So this box here, because it's a collision, it's detecting it as an object. Okay, so our line trace is working. So these objects I used here are provided by Unreal as default, and they've already been set up with their collisions. If you're using it in your scene that doesn't originate in Unreal and you haven't added your collisions to them, then just add your collision, and then you'll be able to detect this line trace working. Now, for example, maybe we've got a lamp on a table and you want to walk up to it, you want to zoom in and get it into focus. Well, just make sure you've got your collisions on first, okay? And then you'll be able to see it working much better. Now, why do I only see a small square? Well, that's because I've only selected it to show for one frame here, which means that I can only see it during that time. Just change it for the whole duration. And now we see that it's creating all of these line traces all the time. And it only shows for 5 seconds. Let me set it to 1 or 2. Let's see what happens. See that now? Okay, so it lasts for 2 seconds and it disappears. See how the trace suddenly stops as well. And that's because it only reaches 4 meters away from the character. As soon as it starts touching, it hits the object. And what we can do here is we could increase it to 5, just so we can just show you something. Okay, so it's hit the object. Let's come around this side. See how the trace is showing? It hits the square and it continues as green after it's hit the object. So what's happened here? Well, we can see this here as a trace color of red and then green. It changes to green. So it's just helping us to see the distance of 4 meters. Okay, so it's detecting the object. Great. Now, it turned green because it detected the collision, and it also detects the floor. So now we have the trace set up. We can get some information which will help us out from this side too. So there's also this feature called hit. Okay, so what does that do? How does that help us? What can we do with this? Well, here you can see that it says hit results structure. So we can break down information, and there is a lot of information available that we can break down from out of this node. So to do it, I'll type break, and there we go. It shows us break hit result. So it's breaking down that node. And if I open it, there are several results here. And I have a lot of variables relative to this trace that is created. Let's check if it's really recognizing the object. So let's choose this one here, hit actor. It gives me as a reference the object being hit. So it's colliding with an actor, and I just put a print string here to help us. So let's add this hit actor information to the print string. Can you see it's converted it as well? So what it's doing is giving the name of an actor. So it knows that it's an actor here, and it's converting it to get a name to display on screen, to get the actor's name and convert it to the print string. So let's press play and see what happens. Okay, so let's see what's happening. We see the message on the floor. It's telling us on the screen, right? Floor. It's detecting that. And it's detecting cube and sphere. So it's identifying the objects that it's colliding with. How cool is that, right? Cool. So to make it visibly or visually understandable, what we can do is this. Let me just save it all first. I'll remove the delay so that you can see the speed of the event tick in play. Look at that. So you can see it's pretty instant, right? It's triggering the floor and showing on the screen many times, pretty much all the time. So if I link delay, it's delaying it a little bit. So I'll put 1 second delay. There we go. So now it's detecting the floor every 1 second. And as the shot's being triggered, it's not just showing it all the time on the screen. So we're actually optimizing the scene a bit more here. And it's still detecting what we want, right? And this is really good for ArcViz scenes. So we can detect the cube, we can detect the sphere, and over here, I think this is cube 5. There we go. And so we can detect all of these different ones. Got it? So this is one of the line trace functions, and it's a pretty good one as well. So that one here, detecting the actors. But for us, knowing the actor in the scene doesn't really matter too much, does it? The important thing is that it's detecting them. And we want to know the distance until it meets the object. So we have a distance variable here. So we can plug that in. I'll link it here, and it's going to identify the distance between the objects being pointed at. So let's have a look. There we go. So from 0 to 226. So it's 226 meters away from the floor. And here, 219. 256 is detecting the distance until this object. So let's see if we can reach the maximum distance. 84. Let me see if I can reach 4 meters away. Okay, yeah, so it doesn't affect it anymore. It's very close to the limit now. 4 meters is the most it can detect. Are we making sense? Good stuff. So 4 meters that we set up is working. It doesn't detect anything beyond that distance. Now, depending on your scene, of course, you might want to adjust that. You might want to make the distance bigger or maybe smaller. But now at least you can see exactly how to do that in this line trace feature. Now we're only using a very simple space. I've seen here how you identified the objects. I certainly recommend you give this a go and test it in your scene as well. Detecting things that are far away might not be needed. So a distance of 4 meters, I'm finding, is really good here. And the important thing is that we detect things that are near us, right? What's the point in detecting something far away in the distance? Although that might be what your project requires. So we also showed you how to detect different things from the break feature here. So that's a really cool resource. Let me use this feature here, promote to variable, and I'll make it object hit distance. Okay, so here we have a added variable, and what's it going to be doing for us? Well, every frame with a delay of 0.25 added in that we put there, with every frame is going to fire a shot, and the shot then is getting the distance at the direction from the camera, drawing then a trace for us, or that red line that we saw in the scene. And then with that, it detects the objects in front of it. And then this variable, which is important for us, will then generate our autofocus. Okay? So that's how that all works. But this is our goal for the first part. In the next class, we'll continue to add more detail. Let's just comment this blueprint now, and we'll call it line trace, or actually get object distance. Okay, so now we're ready to move on to the second part of this particular element. I'll see you in the next class.